pales in comparison to the weather on other planets in our solar system. Hold on tight, because we are about to embark on a journey to the worst weather on one of the solar system's planets. As we're talking about weather and other planets, you might have got the idea where we're going today. The weather here is predicted to be stormy with a chance of violence, and it's none other than the Great Red Spot of the greatest planet, Jupiter, and also the greatest storm of the solar system. The gaseous Jupiter, the king of the planets, may appear beautiful, but it's not worth planning a trip there. The planet experiences massive storms compared to Earth, with thunderheads reaching 40 miles from base to top. That's 5 times taller than anything on Earth. Jupiter also experiences lightning strikes that are up to 3 times as powerful as Earth's largest superbolts. In fact, the weather on Jupiter is so extreme that it can be seen from space. But things get even worse when we move to the famous red spot of the gigantic planet. The Great Red Spot is located 22 degrees south of Jupiter's equator. It has been raging since at least the late 1600s, when Italian astronomer Giovanni Cassini made the first recorded observation of it. It has a diameter of 15,400 miles, which is nearly twice the size of the entire Earth and 1/6 the diameter of Jupiter itself. The storm rotates in a counterclockwise motion, making it an anticyclonic storm. Like a hurricane on Earth, its center is relatively calm, but farther out, the winds scream at 430 to 680 kilometers per hour. That's equal to 270 to 425 miles per hour, with a heat of 1,300 degrees Celsius in its upper atmosphere. This weather might be suitable for aliens, but can you imagine living there in such extreme conditions? When comparing the weather on the red spot to that on Earth, a Category 4 hurricane on Earth has winds of up to 150 miles per hour, whereas the winds on red spot are more than 400 miles per hour. On Jupiter, as with everything else on the King of Planets, the weather is the result of titanic forces that produce some seriously powerful results. If any of these were to happen here on Earth, the results would be disastrous. Consider this to make things easier. The wind can rip the tiles off a roof at speeds of up to 55 miles per hour. Adding 100 more miles per hour, it can now turn cars at 156 miles per hour. And a wind speed of 62 miles per hour is sufficient to lift a person weighing approximately 176 pounds. Now, can you imagine what would happen if we got into the red spot? The question that arises here is that where this beautiful yet violent spot came from. The greatest and most famous storm of the solar system is bounded to the north by an eastward moving atmospheric band and to the south by a westward moving band. Those swirling bands are responsible for the storm's formation and have kept it spinning for more than a century. The Great Red Spot's longevity can be explained in part by Jupiter's lack of a solid surface. Jupiter's sky is 44 miles deep and made up of cloud layers composed of ammonia ice, ammonium hydrosulfide, or water ice and vapor. Scientists believe an ocean of liquid hydrogen exists beneath these layers, and beneath that ocean is Jupiter's core, but scientists aren't sure what it's made of. When a hurricane reaches solid land, it begins to slow and disintegrate, but with nowhere for the Great Red Spot to make landfall, the storm can rage on and on. But the question of when it happened is still a mystery. Here on Earth, we came to know about this red spot in the 17th century. Jupiter's Great Red Spot was first observed in 1831 by amateur astronomer Samuel Heinrich Schwabe, indicating that the storm has been around for at least 150 years. However, it could be even older. Some astronomers believe that when astronomer Gian Domenico Cassini wrote about a permanent storm in 1665, he was referring to the Great Red Spot. For a long time, scientists thought of this red spot as a solid surface. In January and February 1979, NASA's Voyager 1 spacecraft zoomed toward Jupiter, capturing hundreds of images during its approach, including the close-up of swirling clouds around Jupiter's Great Red Spot. This image shown was assembled from 3 black and white negatives. The observations revealed many unique features of the planet, bringing clarity about its atmospheric nature. Another thing that the scientists noticed about the red spot is that it's not static, but is rather moving. But what got them baffled is that the red spot is not the same as it once was. The Great Red Spot might actually be breaking apart. Scientists have been observing the storm on a regular basis since 1850 and have noticed that it occasionally shrinks and grows, but is currently on a shrinking trend. What was once 3 times the size of Earth is now only twice the diameter of our planet. A team of scientists recently analyzed old observations and combined them with new ones from various modern spacecraft, such as the Voyager missions and the Hubble Space Telescope. The archived observations show that the Great Red Spot has grown and shrunk over time. The storm, however, is now quite small, and it has been a long time since it has grown. Researchers recently discovered significant changes in wind speeds with the massive storm, in addition to the changing size. Jupiter's orbit around the Sun takes 12 Earth years. Hubble discovered that winds in the outer ring of the Great Spot increased by up to 8% during the Jovian year between 2009 and 2020. While the wind speed varied depending on when Hubble observed the storm, the telescope did detect long-term increases in the outer ring's rotation speed. Because Hubble cannot peer into the depths of the storm, researchers are baffled as to why the increase is occurring. The fate of Jupiter's Great Red Spot, whether it will continue to churn for many years to come or eventually shrink and disappear entirely, is still hidden behind Jupiter's clouds. As of April 2017, the storm measured 10,159 miles wide. That's about a third the size observers noticed in the 1800s. As the storm shrinks, it grows taller and changes color, becoming a brighter orange. Scientists aren't sure why this is happening, but it could be due to chemical reactions as new material rises from beneath. The Great Red Spot's signature color has several compelling and conflicting explanations. Some scientists believe the red color is caused by chemicals deep beneath the storm's cloud tops. However, other researchers believe the rusty color is caused by sunlight splitting up various chemicals in the storm's upper atmosphere, implying that the rest of the Great Red Spot is not very red at all. We might just catch a glimpse of the sunburn at the top. Over the years, the Great Red Spot has never ceased to amaze the scientists. At high altitude, some 500 miles above the planet's visible cloud tops, temperatures were much greater than would be expected as a result of warming by the distant sun. At first, scientists couldn't find the answer to why, despite being this far from the sun, the atmosphere of Jupiter is hot. Well, the answer lies in the red spot. Acting as a stove, the massive storm is heating the atmosphere high above it to temperatures hundreds of degrees warmer than anywhere else on the planet. Jupiter's atmospheric temperatures are generally around 930 degrees Celsius, with the exception of areas above the planet's poles that are heated by auroras. However, the atmosphere above the Great Red Spot is approximately 1,330 degrees Celsius. This atmospheric heating is primarily caused by a combination of gravity waves and acoustic waves generated by turbulence in the atmosphere beneath the Great Red Spot. This yet uncovers another violent behavior of the giant storm, but to our surprise, it is not the only one found in our solar system. Saturn's atmosphere is roiled every 20 to 30 years by giant, planet-encircling thunderstorms that produce intense lightning and massive cloud disturbances. The head of one of these storms, dubbed Great White Spots after Jupiter's Great Red Spot, can be as large as Earth. In contrast to Jupiter's spot, which is calm in the center and lacks lightning, Saturn's spots are active in the center and have long tails that eventually wrap around the planet. 6 such storms have been observed on Saturn over the past 140 years. This is not just it. Neptune also gets the honor of possessing one such storm, the Great Dark Spot. The Great Dark Spot was a massive spinning storm in Neptune's southern atmosphere that was roughly the size of the entire Earth. Wind speeds of up to 1,500 miles per hour were recorded during this storm. These were the most powerful winds ever recorded on any planet in our solar system. When the Hubble Space Telescope looked at Neptune in 1994, the Great Dark Spot was gone and a different dark spot had appeared in the northern atmosphere of Neptune. With the decreasing size and an increase in the wind speed, it suggested that the Great Red Spot might also disappear some 70 years later, and a new one might take its spot. What do you think about this violent, deep vortex? Let us know in the comments down below. Don't forget to hit the thumbs up and stay tuned for more.